Hi all. Yet again, we've got a pretty serious setup here. We'll be looking at changing B this time for trig functions. Now, hopefully you've watched changing A. We looked at and made all these functions here and experimented with changing A, which is our amplitude. In this case here, we're going to be changing B instead. So what we're going to be looking at is changing B. Firstly, let's do it for sine, and then we'll be doing it for cosine, then tangent, and seeing what B does. A key piece of information is that we have to look at the period first. So what's the period? Well, the period is the distance required in angles to go and repeat that pattern. So here, right, if I go all the way to here, 180 degrees, we can see I've got that pattern like that, but it goes down and then back up, right? So to actually repeat the pattern, I need to clip out a full revolution or 360 degrees of this graph for me to control copy. You can see this here, and it's exactly the same here. So therefore, I found the period of the function. It's basically how long does it take for it to repeat its pattern. So we'll be changing that today, okay? So let's just graph something, sine, and we'll start off with a simple one. The most standard one is y is equal to sine 2 of x. Now let's make that blue. Y is equal to sine 2 of x. Now we know before that sine of x, we knew that it was sine of x was, the period, sorry, was 360 degrees. So now let's have a look at the period. Well, if we're blue here, right, we follow the graph along, and this is y is equal to sine 2 of x. So b, the factor here, is going to multiply the scale factor's a half, and so basically it's squishing our graph along the x-axis by a factor of a half. So let's have a look. We can see that it's gone here, 90 degrees, but the pattern continues to here, 180 degrees. So our new period is from 0 to 180 degrees, so the period in total, the total angle is 180 degrees. So we can see that relationship there. We can also see that this graph has indeed squished along the x-axis. Let's try one more, and I might have to delete the other one because it's a little bit confusing when you start plotting all these. Let's go a third. Let's chuck that in there, and let's go 1 on 3 x like that. Okie dokie. Now what we need to do is we need to change the scale axis on this. Okay, so I'm going to go to 720 degrees, and let's make it a half actually, just so we can fit it all in. Okay, and let's get rid of that. So we can see here that if b was a half, then it's going to go 1 divided by half, which is 2. So it's going to double or stretch out our graph by a factor of 2 along the x-axis. See how we're not going this way. So let's have a look at the pattern. We can see just here, let's see if I can click that. There we go. Negative 360 degrees. It goes down there, but we haven't repeated that pattern back here, and we're repeating that pattern there. So we can see here that the period has indeed stretched this time. So it's gone from 360 degrees to 360 plus 360 in total, which makes 720 degrees. Now, if you look at our formula here, 360 divided by b, and b in this case is a half, 360 divided by a half is indeed 720 degrees. So that's how we calculate the period for a function like that. And we can see that it has indeed dilated by a factor of 2 along the x. Cosine, very, very similar. And we won't dwell too long on it. Let's just say cosine, and it's going to be 3x this time. We'll just look at one of these. Okay, so cosine 3 of x, so we're expecting the graph to be squished by a factor of a third along the x-axis. That means we're squishing it. So if we have a look at this, we've got sine and cosine. The period is 360 degrees divided by b. b in this case is 3, so 360 divided by 3 is 120 degrees. So we're expecting to see a period of 120 degrees. Now we can go peak to peak, or we can go min to min, or we can go x to x value. I'm going to choose peak to peak this time, a bit easier. 0 goes down, back up, and then the pattern repeats again. So we can see here from 0 to 120, the distance is 120 degrees between these points, therefore the period is 120 degrees. As we can see, the amplitude hasn't changed at all. This b value only changes the period. The very last graph we're going to look at is tangent. Now tangent the one we all love, we're going to have a look at transforming this. Now, let's have a look at our period firstly. Well, we know that there's a x is equal to negative 90 asymptote here, and also a x is equal to 90 asymptote here. So that means what's the period of tangent? It isn't 360 like the other graphs, it's 180 degrees, because you can see if I copied this pattern and then pasted it again, we're just repeating that pattern over and over. Therefore, we have 180 degrees to play with rather than 360. So let's experiment with the graph. Let's type in y is equal to tan, and let's go a half x. Okay, and I'm just choosing simple ones here, and let's make that nice and green. There we go. So let's have a look at our graph here. We can see that this graph has changed. Okay, now let's think about what we've done. If we have a b value of a half, then what's our new period going to be? Well, the period's going to be 180 degrees divided by a half. Dividing by half is the same as timesing by 2, so our new period's 360 degrees. What does this mean for our x is equal to negative 90 asymptote here and 90 asymptote? Well, they also get pushed out because this does get affected by dilation because we're pushing everything out. So what's going to happen to my x is equal to 90 asymptote? Well, I'm also going to stretch this or multiply this by a factor of 2. So if I put in a 180 here, then the asymptote should seem to match the green graph. Let's have a look. That looks pretty good. And therefore, we're also going to multiply our negative 90 by 2 to make it negative 180. Not that. There we go. Okay, and we can see here that our green graph is approaching that asymptote nicely. So when we're doing tangent, we need to note that our asymptotes also get squished, transformed along with our b value, along with the rest of the graph. Now we remember that our key point, what was it before? Was it 45.1? So where's that going to go now? Well, it's now going to go. You're going to times the x value by 2, so it should go to 90 degrees 1. So let's have a look. 90 degrees 1. There we go. So we can see here, and let's put that key point in. 90 degrees 1. I'm going to label that, and let's put in the 45 degrees 1, just so we have our key point. Okay, so what we're going to do now is I'm going to take a screenshot of this, and I'm going to stop the video there.